Great, guys. Be nice. All right, so today what we're gonna do is we're gonna finish up on this lesson, and we're gonna start on this page right here. This right here is on your cheat sheet. So it's the second thing on the cheat sheet. This part we went over on Friday. If you weren't here on Friday, you'd have to either watch the videos or look at the completed notes. And then this part right here is what we're handling today. Okay? Now, what is going to happen today is, I think I'm gonna actually go here and I'm gonna use this example. What's gonna happen is the first sentence needs to be in if-then form. And the symbols that represent if-then form are this right here. So this means if P, then Q. So our equation that they have is if the measure of angle A is 35, then angle A is an acute angle. So let's first of all think of that statement. Is that true or false? If the measure of angle A is 35, is angle A an acute angle? True. Okay. Now, the next thing, we're just switching these around. Okay, that's enough, boys. We're just going from the original if-then statement, which I should tell you guys, that's called a conditional statement. What they're gonna do today, and what you're not gonna like about today, is you have to write 3 additional statements. Sometimes that first statement is not in if-then form, so you have to write that first. Then you have to do what's called the converse, then you do what's called the inverse, and then you do what's called the contrapositive. If you pay attention to this, it's not hard, it's just time consuming. So to get from your original, they call it a conditional statement, to the first one, which is called the converse, what they do is they take this statement and they flip it around, okay? So rather than saying, if the measure of angle A is 35, then angle A is an acute angle, instead of that, they flip it around and they say, if angle A is an acute angle, then the measure of angle A is 35, okay? So what they do is take this one and they flip the front and the back, and that is called a converse. Now, is this a true statement? If you have an acute angle, is the measure always going to be 35? No, okay? Now I'm gonna give you guys a trick. If you have all 4 of these 2 can be hard to tell if they're true or false. And the reason is we're gonna be talking about these symbols right here. Do you guys remember what those symbols mean? Not. So what happens in these 2 sentences is you have the word not many times twice. And it's hard to tell if it's true or false. So here's what we do. Whatever truth value the first one is, that's what the truth value of the last one is. Those 2 are always the same. Then, whatever truth value the middle or the second one is what the truth value of the third one is. These 2 are always the same. So I do the truth values for the first 2, and then I use these rules to find the truth values of the third and fourth. Now, we did this one. Now we have to do this one, and what this is not P implies not Q, or if the negation of P, then the negation of Q. What you do is you go back up to this thing and you negate both of the sides. What that means is put not in to both sides. So if we look at this, it's going to say if the measure of angle A is not 35, then angle A is not an acute angle. Do you understand that? You put the word not in the if part and the then part. So that's what they did here. They put the word not in the if part and they put the word not in the then part. That's taking care of these squigglies right here. Okay? Then, when you go to do the last one, there's two different ways you can do it. Notice here we have if not Q, then not P. People do this two different ways. Some people go back up to the converse and they negate both sides, and then it would look exactly like this. So they would go up to this statement and they would say, if angle A is not an acute angle, then the measure of angle A is not 35. Okay? Other people would do this. Notice these two are just the opposite of one another. Like it's taking the front and the back and flipping it. So some people instead would go to this one and they'd flip the front and back. Which way you do it does not matter. You choose which way to do it. Now, sometimes today that first sentence is in if-then form. So that means you do, the next three. Other times today, that first sentence is not in if-then form. You would write it in if-then form and then do these three. So on those problems, you'd have 4 parts. Okay? So we are going to go to this page right here, and we're going to try this. Okay, so this says 2 angles that have the same measure are congruent. That is not in if-then form. So for the first thing, we have to write it in if-then form. And that is called our conditional. And the symbols for that is P and then it yields Q. Okay? If I was writing this in if-then form, you have to figure out where you're going to split it. And I would split it right here. Okay? So I would say this. If 2 angles have the same measure, then they are congruent. Okay? If 2 angles have the same measure, then they are congruent. So let's talk about this, guys. Is that a true statement or a false statement? It's true. So that means this one's true, and I can mark that, as well as my very last one is true, because the first and the last always have the same truth value. Okay? Now, when you go to do the converse, that is just going back up to your original and you switch the front and the back. So you could even say, if they are congruent, then the 2 angles have the same measure. So I'm going to do that. If they are congruent, then the 2 angles have the same measure. Now, I have to decide if that is true or false. So let's think about that. If you have angles that are congruent, would they have the same measure? Yes. So that means this is true, and then wouldn't that one be true also? Okay. So now we have them all written as true or false. Okay. Now, the next one is called the inverse, and if you look at it, it's not P, then not Q. So here's what I would do. I would go back to my original statement, and I would add the word not to both sides of the sentence. So I would say if two angles do not have the same measure, then they are not congruent. So if two angles do not have the same measure, then we would say they are not congruent. Okay. Now we have to write our last sentence, and kids do this two different ways. This one is not Q, then not P. It looks like this one, except I would have to negate both sides. So I could go back in this, and I could put not with the beginning and not with the second part. So I'm going to do it that way. I'm going to say, if they are not congruent, then the two angles do not have, whoops, the same measure. Ironically, like if you looked at the math standards from the state, there's some that are very generic that things kind of fit into, but there's a separate standard for this type of problem right here. Like it actually says in the standard, like given an if-then statement, you can write the converse, inverse, and contrapositive. So like if you're thinking Mrs. Button has lost it, why is she teaching us this? I truly have to teach you guys this. So it's something that is a state standard. Okay? Do you guys think you get that kind of question? Is that okay? All right, now we have to learn one additional thing. And for this, I am going to have you guys copy this down somewhere, or actually go to the back of your cheat sheet. You have quite a bit of room down here. Copy this in purple, or if you would rather, copy it directly from the note packet so you can see it better. That would be fine too. Okay? So copy this down, and then we'll go over some questions on it. So the last thing that we have to talk about today is something called a biconditional. And so what's gonna happen is they're gonna give you a statement, okay? And a lot of times it's not in if-then form. In fact, most times it won't be. So let's say they said, Rocori Spartans have a Spartan for a mascot, okay? So the very first thing you do is do that in if-then form. So it'd be, if you go to Rocori, then the Spartan is your mascot, okay? And you decide if that statement is true or false, which it is true, correct? We all know that. Then what you want to do is take that statement and do the converse of it. And the converse is the one, if then is P dash Q, and then the converse is Q dash P. So all you do is you take the two sides and you swap them. So this one would be, if your mascot is a Spartan, then you go to Rocori High School. Do you guys think that's true or false? False. Aren't there schools and even college that have a Spartan as a mascot? So that doesn't mean you go to Rocori if your thing is a Spartan. So this one was true for us. This one was false. Then what you do is you go back to the original statement, not in if-then form, and you write it. And I think it was something like, Rocori High School has, how can I say this? Rocori High, probably isn't the best example, but I'm gonna say, you are RHS student, and then you write if and only if, okay? This is something we'll see quite a bit in geometry, is if and only if, and there's an abbreviation for it that's IFF. If you ever see IFF, that means if and only if. What it means is your sentence is true if you read it forwards, and your sentence is true if you read it backwards, okay? So you are an RHS student if and only if your mascot is a Spartan. Okay, so that's our sentence. And then what we have to do is decide if our whole biconditional, which is this last one, is true or false. The only way this is true or false is if both your original and your converse are true. If these are both true, your overall is true. If either of those are false, your overall is false. These both have to be true. Okay? So let's look at what your assignment could look like with this. Okay, so it says rewrite each statement as a biconditional statement. Tell whether the biconditional is true or false. Okay? So the very first thing that you guys have to do is write this in if-then form. And it's lines that do not intersect are parallel. So we're gonna say that this. If you have lines that do not intersect, then they are parallel. If you ever need to make a symbol for parallel, you guys, 2 vertical lines means parallel. We'll get to that in a while, but if you ever want to abbreviate it. Now we have to say, is that true or false? If you have lines that do not intersect, are they going to be parallel? Yes, okay. This actually is false, but we don't know that yet. So we're gonna just assume this is true. Because from what you guys know at this point, that's a true statement. Now what we're gonna do is write the converse of this purple statement. And converse is just switching it around. So we're gonna say if lines are parallel, then they do not intersect. What do you guys think of that statement? True or false? If lines are parallel, do they not intersect? Yeah, so that's true. Now, the last thing is that we're gonna write what's called the biconditional. When you write the biconditional, you go back to this original thing. Yep.
Can you write the parallel line sideways instead of up and down?
They have to be up and down. Okay. Yep. When you go to do this one, lines that do not intersect, are they parallel? We're gonna say this, lines do not intersect if and only if they are parallel. So when you do your biconditional, you don't come back to these, you go back to the original, and you basically put IFF where we split it. So we're gonna say lines do not intersect if and only if they are parallel. So we're gonna say lines do not intersect IFF for if and only if they are parallel. And the parallel line symbol is vertical, but of course you can have parallel lines that are horizontal, that are diagonal, but the symbol has them vertical. Now we have to say if that overall is true or false. If these are both true, what's our overall gonna be? True. Okay, perfect. Now we have one more. Okay, so we have this statement that says the game will be canceled if it is raining, okay? And you're gonna decide where you wanna break it up. And for this one, I would say break it up here, okay? And actually, if the game canceled, then it is raining. Okay, we can say that. We're gonna say if the game will be canceled, then it is raining. So that's our conditional. If the game will be canceled, then it is raining. Okay, let's think of that, you guys. If you cancel a game, does that mean it's gotta be raining? No, there's other reasons, right? It could be bad roads. It could be players got sick. It could be there's a power outage. There's many different ways it could be, but this is gonna be false, okay? Now we have to write the converse of that, and we're gonna say, if it is raining, then the game will be canceled. Okay, what about that? For every sport, if it's raining, do we cancel it? No, right? Basketball's inside, volleyball's inside. Football, we don't cancel just for rain, right? It has to be lightning. So, yeah, so this one's false also, okay? Now they want you to write it as a biconditional. So you go back to this original, and right here, you're gonna add IFF for if and only if. So we're gonna say the game will be canceled if and only if, which is IFF, it is raining. Now, for that final thing to be true, both of our original statements had to be true here, and they're not, so this is false. Is that hard? Just time consuming, you think? Okay, so here's your assignment. Now you guys are gonna have to pay attention to which ones you have to do conditional, converse, inverse, contrapositive, and which ones you have to do the biconditional. Okay, let me check.
Say you swear.
I wonder why that is all the time.
Because you probably didn't do like our tasks, you're doing it right now. Like in the weekly snapshot,